Hey, hello everybody. I am looking for. Uh, can you speak our people? I remember you. Our blog is blog doc tgd blog doc ex. Let's go, Andrew.
Thank you, Mario. Hi, Orestes. Hi, Edgar. How are you today? So, so that's true, Orestes. This is our 12th, I think, production since we started this lockdown something like 40 days ago. That's crazy. And we have today a person that is a friend and also it's a very nice developer working on the with the Open Source Vision Foundation, OpenCV, a very well-known library for machine learning, artificial intelligence related to the vision. So with the Differentiable computer vision talk and introduction to Cornea, I'm going to let Edgar to make his presentation. And thank you, everyone, for staying with us again. Edgar, your turn.
Okay, thank you, Andrew, for the introduction, and thank you as well for inviting me here and giving me the opportunity to give this talk and a voice during this period of lockdown. So let me first introduce myself. I'm Edgar. I'm a PhD student at the Computer Vision Center in Barcelona. Right now, I'm also working as a research scientist at the Robotics Institute, doing research on computer vision and deep learning. And I've been involved on the open source community for quite a long time ago. So basically contributing to projects related to computer vision, also robotics. To mention some of them, the ROS, which is the Robot Operating System, Open Drone Maps, or Open SFM, which are more related to vision and 3D reconstruction stuff. But also I've been quite involved in the OpenCV library, which is more or less the topic around I'm going to talk today. So as Andret said, the OpenCV library, it's a computer vision library. It's open source. But at the same time, there is the OpenCV Foundation, which I'm part from. So the OpenCV Foundation goal is somehow to promote the use of basically OpenCV itself, but also to promote the computer vision within the community. And for this, we try to work towards promoting this through, for example, the Google Summer of Code program, which I've been involved as a student, I think 3 times, and now as a mentor. And the idea is to let the students and community, the computer vision community, to grow. Okay, so and for this, in the foundation, I'm also part of the Cornea project, and actually in the project leader. And now I'm going to explain. Well, this presentation will cover more or less an introduction what's Cornea. We'll give you more or less the details and some of the roadmap for next releases. Okay. So the title of this presentation is Differentiable Computer Vision, which is basically an introduction to the Cornea project. So for all those that are familiar with computer vision, probably machine learning, and now deep learning, you probably know that this is now this huge ecosystem for frameworks, platforms, okay, that mostly try to connect all these pieces all together. For example, you have frameworks, recent frameworks for deep learning like PyTorch, TensorFlow, MXNet, and other existing stuff for scientific computing like NumPy, high-level frameworks like FastAI, PyTorch, Lightning, Keras, frameworks for interchangeate formats within frameworks like ONNX, and also different platforms for high efficiency computing like the NVIDIA CUDA. But the big question here is when I started this Cornea project, the main question here was what is the classical or traditional computer vision within all these frameworks? And the question for that, or the answer we found, is that within this, let's say, big ecosystem, there is there was this black hole around traditional or classical computer vision. And basically, this is the reason of Cornea. So Cornea, it's an open source differentiable computer vision library for PyTorch. So meaning that we implemented basically some of the classical algorithms for computer vision using PyTorch as a backend, taking all the advantages that PyTorch can give for us. Okay? And basically what it means as well is that now in Cornea, you will have more or less the same functionalities you had in OpenCV, but now inside the PyTorch ecosystem. In the sense that now you can use all these OpenCV functions within the system ecosystem of PyTorch and using them for training your neural networks. And this means that you can have any operator use it between the networks and backpropagate through that. This is the main idea behind Cornea. So as I mentioned, Cornea inherits a lot of properties from PyTorch. So for example, this is probably the most important, differentiability. So Cornea inherits a differentiability property from PyTorch. As I mentioned right now, you can use any of the operators that you could use before in OpenCV, but now you could use it in Cornea in a differentiable manner. Second, we have a transparent API that also, thanks to Python, we can run the same algorithms being agnostic of the device they run. So you can run the same line of codes in the same device like CPUs, GPUs. Now we are starting to explore the TPUs. In addition, we inherit also the parallel programming by default from PyTorch. So everything happens in batch. And also we can use Cornea with the distribute API from PyTorch, meaning that you can do all the processing in the cloud. And finally, you can use Cornea for production using the just-in-time compiler that will optimize your low-level algorithms for production. So this is more or less the core features. And here, for example, I show very briefly a snippet with all these capabilities that you can load a batch of data, you can put it in a tensor, a batch tensor with a line of code using the PyTorch API. You can send it to a GPU device. You can define your sequence of operators, defining with this functional. You can send this functional to a distributed cloud, defining any number of nodes of your system. And finally, you can infer any tensor, image tensor, or features tensor to this operator. So in the end, Cornea, what it is, it's puts the classical computer vision in another step. So we are not assuming, as all the computer vision libraries, RGB images, but we can operate within tensors, n-dimensional tensors. So next, I'm going to go through the different functionalities we have in Cornea. So in Cornea, as in the other computer vision libraries, we have more or less this internal structure covering all the different computer vision, say, areas. For example, this is probably the big picture of more or less what you could do in Cornea. So you can do color transformations, image enhancement, you can do filtering, you can compute features, you can apply geometric transformations to images. So this is more or less what you can do in traditional computer vision libraries. But now you can do the same inside the PyTorch ecosystem. So let me go through the different components we have. So the first one, it's the data augmentation module. So for all familiar with this, during the training for neural networks, data augmentation, it's something very powerful because you can create new sample for that. So basically now we recently introduced this API that it's fully compatible with the existing one in Torch, in this case, Torch Vision. And in addition, we have added other new features that are very powerful, we think, for research, like you can retrieve the transformations you applied. And everything happens in Torch tensors. Everything can be done in the GPU in parallel. So, and for this, we also designed this API in a way that it's easy for the users to create their own things. So it's not really a black box. Everything is very simple and flexible. So some other examples of what you can do with this data augmentation API is changing the properties of your images. You can see here in the bottom that you have for images. It means that it has been computed in a batch. So everything in parallel. So you can do the data augmentation in a batch mode, changing the different properties from the images, like the gamma corrections, saturations, the hue channel. Then you can do, well, we have also this color transformations model where we have implemented, re-implemented all the color transformations that you can usually find in, let's say, OpenCV, Scikit, and all the high-level packages, like conversion from RGB to grayscales, or BGR to HSV, LUB, LIB. So you can do everything now in Corneum using Torch tensors. Everything is also backpropagable, so you can backpropagate through all these nonlinear color conversions as well. Next, we have, I think, one of the most, to me, interesting modules. It's for 2D features detection. So the community for features detection, they have already a lot of libraries implementing these algorithms. But the interesting thing here is that we have also implemented some of these algorithms in PyTorch, like, for example, to compute the Harris corner responses, the Hessian responses, the difference of Gaussian algorithms. We have also a scale space framework that you can extract features or patches from an image pyramid. We have also soft and non-soft versions of non-maximal suppression. And actually, one of the cool things we have is that we have the SIF descriptor, also is differentiable. And we recently introduced some algorithms implementing descriptors using neural networks, like HARNet or SOSNet. Another model we have is for to do more traditional image filtering, like, for example, applying blurring to images, very common operators like the box blur, median blur, or Gaussian blur. And as well, everything is differentiable. You can run it in batch in the GPU. And same for edge detection, operators to compute edges. Here I show just an example of the Sobel edge detection. We have also the algorithm for computing Laplacians, or just the gradients in X, Y, Z. That everything can be done in the image level, but also in the features level. So we can compute actually the derivative coming from some tensor features. And everything, in this case, for the edge detection and the Gaussian blur, it's based on the convolutional operator in PyTorch, which is very highly optimized. Finally, well, not finally, we have also these geometric image transforms. Basically, this module deals with 2D geometry transformations. Also, we are now starting to explore the 3D geometry. We have also different linear algebra for camera projections, operators to work with RGB as well. Here, I just show for the 2D examples, something we can do like flip images, apply rotations, perspective transformations. You can do crop, or in this case, a chained transformation of crop and rotate. Then we have more high-level things like this warp affine or warp perspective that we inherit, for example, from OpenCV, when you can just input a tensor, and then given one transformation, you can apply some transformations. Or simply having correspondence points, you can compute all in a different manner the transformation you will get using this set of points. And yes, now finally, we have also these vision and loss packages where we implement some of, let's say, not common losses from what we now understand in the deep learning framework. So are very specific losses like a total variation, or a structural similarity index, PSNR, that usually are used for removing noise in images, or now we introduce losses for semantic segmentation, like focal losses. We have also some losses for computing the divergence between heat maps. So quite a large list of losses that are very specific to computer vision. So now I went through the different features that we have in Cornea. So let me now introduce or give a small introduction about how you can start using Cornea, the development of Cornea. So first of all, how you install Cornea. So actually, it's very easy. So we have the package in PyPy, meaning that just with a pip install Cornea, you can get your Cornea package installed in your computer. So and one, I think, cool thing from Cornea is that we have only one single dependency, which is PyTorch, meaning that if you have PyTorch in your system, you download Cornea, you run it, and everything works out of the box. So you don't have to compile anything, you just download and run. Okay. Something that I want to announce today is that we release the version 0.2.1. So that mainly, as I was explaining for the data augmentation module, we now cover or we are compatible, let's say, with the existing packages like Tor Vision and other packages. Second, easy to use, as probably as you have been noticing during the talk, because I've repeated a lot of times, is that everything happens at the tensors level. So basically, what I would like to highlight here is that any function of a Cornea assumes as input a torch tensors, and everything can be computed very efficiently in that way. Second, well, third point here is that since we have been inspired in OpenCV, we have for most of the functions, we have this OpenCV syntax. So for example, here, just to give an example how you could apply a Gaussian blur using OpenCV, and in line number 6, it's the called Gaussian blur. If you see on the bottom how you could use that in Cornea, you will notice that the API is, let's say, almost the same. So we tried to make this consistency between the two frameworks, OpenCV and Cornea. And another example for the same is that this transformation word perspective, that it's a very used transformation in OpenCV. So in Cornea, you can use it in a similar way. With word perspective, it's more or less the same function signature. You feed the same parameters and input, in our case, a tensor, the transformation, and you finally define the output, the expected output of your transform. Yeah. More things. Also, Cornea integrates with existing torch-related projects. One of these is, as I mentioned before, the torch vision. So we are now compatible with torch vision. So we can run the same functionalities from torch vision. You can do it now in Corneum. And from that side, we introduce some new features like retrieving the transform you applied. And then we have also, well, recently we started some collaborations with this project. It's called PyTorch Lightning. So basically Lightning, it's a high-level framework for training neural networks that it's very simple to use. And we started to these collaborations because we wanted to see how Cornea can be used in real use cases. No? For example, in this case, how you can easily integrate Cornea with 3, 4, 5 lines, the data augmentation in these end-to-end frameworks training systems, right? So yeah, and if you have time, we have also examples, or you can ask me later about that. But it's a very cool idea to integrate all those things. So, and finally, let me just go very quickly through the examples we have. So basically, in these examples, we have these high-level examples where we would like to show the property of differentiability. So in during the start of this talk, one thing that I mentioned is that we inherit differentiability from PyTorch. But what does it mean? So it means that using the Cornea operators, so now you can solve problems from traditional computer vision that usually, for example, in this case, the Lucas Canade, which is it's an algorithm that helps you to solve the image registration between two images. So in the traditional way to solve that, you could have to write down the derivative to solve this problem. But using the high-level operators from Cornea, since we use as a backend the PyTorch autograph engine, which computes the derivative for you. So this will happen everything automatically. So there is no need anymore to write down all these derivatives to solve this kind of classical problems. Some figures here. These figures are actually from the paper we submit to the Winter Applications conference that I'm gonna explain right now. More problems that Cornea could be helpful is, for example, we showcase how you can solve multi-view depth estimation with similar ideas where you can just apply, in this case, projective geometry to solve the depth, and taking advantage of the same property, differentiability, where you can build complex loss functions and you don't have to explicitly compute the derivative by hand. Everything will happen automatically using the Torch autograph engine. Another interesting problem that we tackle here to show differentiability is the case for feature matching. In this case, we use as I mentioned before, for the 2D module that we have now these differentiable sieve operators. So in this case, we want to showcase, for example, when you have two images from two different domains, and you want to optimize your algorithm to make these two images to match. So using all these differentiable operators, you can detect your features and then optimize the two images so that the algorithms finds a robust match between the two images. Okay. So this is another example that it's detailed explained in the paper. And now I more or less talk about how is Cornea design and all these components. But here now I would like to explain about the Cornea ecosystem. So Cornea, it's an open source library as its name reflects, which means that now we have, from the beginning, we have the code available in GitHub. it has an Apache 2 license, meaning that you can download the code, you can modify, you can make a product, sell it, get some third-party products from that. And we started also to get more contributors. So we started the project 2 years ago, and now we have in GitHub the way we measure that, because in open source sometimes it's difficult to track how many people is using your project. So a mechanism we have is the GitHub stars. So and right now we have more than 2,200 stars, more than 254, so meaning people that is already forking the project and starting to touch the code, let's say, and more than 50 contributors already sent a pull request to the project. And yeah, as I mentioned, that the project started 2 years ago, more or less. At the very beginning, the project that was called PyTorch Geometry, we were doing just the geometry part, but then we realized that the more and more we integrated vision functions that probably could make sense to have, instead of just geometry, why not having more generic computer vision things, right? And this is the main reason why we refactored the whole repository and we created Corneum itself. Okay. If you are questioning yourself about the name of the project, because a lot of people sometimes ask me why Cornea. So Cornea, it comes from the cornea eye, because since we are doing now computer vision, no, the cornea eye, the cornea takes into account the perception, no, and it is very related to computer vision. So as I mentioned, we submitted a paper to the Winter Applications Conference that happened 1 month ago. And basically, we wrote in details, so all more or less what I briefly explained it here in the presentation. We have all the details, all the formulas, some benchmarks, and more experiments about all the use cases. The paper is available in archive, so I think I will share these presentations, or probably from the recorded video you can get the link to the paper so that you can read it. And basically, this project I started at Array. I started this project with Gary, which is the father of OpenCV. And that's also the reason why it's very inspired in OpenCV, but also in collaboration with the Computer Vision Center, where I'm doing my PhD, also with the Prague University. Dimitro is the other maintainer of the library, which is from the Prague University. And then once the project started to get more interest, so PyTorch itself includes the project as part of their official ecosystem, and they are time to time giving us some support. And also AWS open source is contributing with us, helping with providing some resources for the GPU testing. And then a lot of organizations, small startups are starting to use more and more Cornea. In addition, we recently found that already some papers are starting to use Cornea. So in the wiki, in the GitHub repository, we have a list with some projects that already are using Cornea. So the ecosystem is starting to grow more and more. And then, as a future plans for Cornea, what we are trying to focus now is to improve the data augmentation model, to start, or not just adding operators, but try to create a bit more the API, so that can be very usable for new users. Also, we want to go or to explore more the just-in-time compilator, so that we can get all the operators more optimized. And also another interesting path that we are exploring is the structure from motion. We want to start adding to Cornea all those functionalities used for 3D reconstruction or epipolar geometry that could be very useful for those cases, or even for robotics to do a SLAM, these kind of things. And as usual, the project, as I said, it's open source. Any contribution, feedback, it's always welcome. Everyone is welcome. So contributing, it's not only sending code contributions. It's sometimes about just filing issues or just giving feedback through the social network. So it's very easy to contribute in open source project because sometimes people think that contributing to an open source project it's sending pull requests, knowing just how to code, but you can do other kind of contributions. And well, now I have a few slides just with some pointers to resources we have. These ones is more for users. So we have full online documentation that it's auto-generated using Sphinx, with the docs, all open source frameworks for that. And we try to keep more or less the documentation being updated. So what else? And then we have also the discussion channel in the PyTorch channel. So for answering questions, we recommend to use this channel to do that. There is a large community there also answering PyTorch related code. So now you can use this resource to ask Cornea questions. And then more for developers, we have always calls for people that want to start contributing in terms of coding. And then we have a contributions document explaining all the things you need for actually contributing to the project. Some extra material, like we have a repository with some examples that now we are trying to work more and more and add more examples in that. And also, well, in the online documentation, we have how to generate the tutorials so that people can start to learn how to use Cornea. So, and I think that this is more or less the presentation about Cornea. So feel free to go to the website. It's cornea.org. You will have there links to GitHub, to the documentations, all the news we have. We try to be active in Twitter, like just promoting the things we are implemented or things that we are exploring. And then, of course, the main resource in Cornea is the source code itself that it's in GitHub. So this is where everything is happening. And also recently, we opened a Slack channel. So if you are interested into getting more details about what's happening during the development process, the channel is open. You are also very welcome to come there and start discussing or being involved of the development discussions we have there. So I think we have still some minutes before when of time, and I'm not sure. I'm going to check now if any of you have some questions that I will try to answer. So let me go through that. Okay, let me open the camera. I think you can see me here. Okay, I'm gonna read some of the questions you have. For example, David Tordas is asking to be processed my machine learning, for example, to detect some object, the face, making image transformations is necessary. Well, to answer this question, I think yes. I mean, of course, it's necessary. I think that's more or less what you are trying to ask here. I think it's more related to the data augmentation thing. So, to be honest, now for these obstacle detections, there are more deep learning based algorithms that probably outperform traditional algorithms. But yeah, definitely could be also interesting to see how the classical algorithms for object detection implemented using these new frameworks, how they perform. Okay. Another question I have from Vadim Stupakov. He's saying, are you going to implement image efficient decoding? About decoding, I don't think in Cornea we are going to go through that direction, since we are more focused on the algorithms itself. So I think this is something that, for example, I think Torch Vision is trying to do to make their own efficient decoders. Also, there are some libraries like NVIDIA DALI that they do this quite efficiently. But I think that from Cornea side, I'm not sure that in the midterm we're going to go through the direction, since we are trying to be compatible with all these other libraries, like Torch Vision, or even in DALI we have done some experiments. I don't think that makes sense to redo the same work they do. Okay. Another questions I have, as a researcher, how do you think that differential transformation will evolve? We have seen papers on it, but it's not something widely used in the community. Cadal competitions, for example. Okay. Yeah, the differentiable transformations, I think it's a path that now it's starting to be used more and more. I think there are just probably, let's say, less than 10 papers implementing that. But I think that it's a very promising area to explore. Okay, because usually the problem for deep learning is that you need a lot of data, and basically the problem that tries to solve the data augmentation is creating more, let's say, artificial data, no? And having this differentiable will make this to be, I think, more efficient, let's say. So yes, I think it's yeah, it's a good way to go, at least to have to explore and get some results and see where we can go with a differentiable image transformations. Okay, another question from the same guy. How Cornea interacts with NVIDIA Apex and mixed precision? Can some transformations, if done, can be done in mixed precisions to speed process? We didn't test yet with half precision. This is something that we like to explore. So right now we give fully support to CPU. We do a local test on GPU. So that the GPU devices are tested, not in a continuous integration system, but we can assure that it's tested. But it's something that we will have, we'll start to work right now to give more coverage for other devices or other data types like half precision. But right now, to answer your question, we don't have any benchmark for Apex. More questions. Camilo Buscaron, are there examples on how can I optimize my algorithms? Yes, in the last slides, I mentioned that there is we have a repository under the Cornea organization that it's called Cornea Examples. And there we have all the examples, tutorials. So yeah, any of you, if you go there, you will have all the examples I mentioned during the presentation. And as I said, we are trying to grow this list more and more. Everything all the examples, we try to make it in Google Colab, so it could be easy to reproduce the examples on your browser, but also you can download the code, you can run it in your local machine. But yes, we have examples. Another question from David Ordaz. So Cornea Torch can be used as an image editor library to correct some picture. I think yes, because we cover some of the, let's say, more traditional image processing algorithms. So I could imagine that someone, could implement an application for that to create an image editor library. So why not? That would be great to see this project. Another question, will Cornea support image decoding as NVIDIA? I think it's the same question, or I read that before. Yeah, so no, the image decoding, no, as I said, we don't think we will cover that for now. Another question, how to auto augmentation can be performed using Cornea? Is there any loss function available in Cornea for such use case? So yeah, this is a good question, because we have almost all the API that is tested for backpropagation, the data augmentation, but we don't have yet, let's say, an end-to-end example, something that we are working right now. So right now we just give the full API that it's more or less functional, but now we will start to add more examples for that. But as usual, if anyone have already an example, it's very welcome to contribute on that. And the last question, as seen in the slides, what is the most common use case of Cornea? Maybe recover too much pixel image? Okay, this is a good question. Which is the most common use case? Actually, I'm not sure there is yet a most common use case, because everything is very experimental. So this is actually, this is one question that I get very often, and that how do you use Cornea? No, and actually, we cover a lot of operators that are ready to be differentiable, but to be honest, we haven't tried all of them. Actually, we give all the API to the users so that they can start to create new things. But yes, what you mentioned, actually, it's one of the use cases, but I think that there are way more different use cases where you can use backpropagation. For example, for image decoding or image reconstruction. These things haven't been explored yet. How to use for example, color conversions or these kind of things as part of your loss function. Yeah, you can do it now with Cornea. You have all these algorithms to convert between color spaces in a differentiable manner. Why don't use it? Well, I think that there are no more questions. And I think that we are more or less on time. I'm not sure about Andreu and the guys here. If you have some comments, or there is a closing for this session. From my side, thanks to all of you, and again to GDG to invite me here, and everybody that has been online answering, asking questions. So from my side, I think I will close this session. So thank you very much all.